I thought of making my own Arduino was easy. I was very wrong. Before we get started, I would like to thank JLCPCB for sponsoring today's video and supporting this project. If you're designing your own PCB, whether you're a beginner or an experienced engineer, JLCPCB makes the manufacturing process incredibly simple. All you have to do is finish your PCB design in software like Altium, KiCad, or EasyEDA, export your Gerber files, and upload them directly into the JLCPCB website like this. So you press Get Instant Quote, and then you upload your Gerber files. Once your files are uploaded, the website automatically analyzes your design and lets you choose options like board color, thickness, copper weight, and quantity, and shows you the price instantly. If your project needs assembly, you can also use their PCB assembly service by uploading your BOM and pick-and-place files, and they will solder the components for you. PCB assembly. Over here you can do different designs, delivery format, PCB color, thickness, FR4, flexible, aluminum, copper, PCB assembly, stencils, flex heaters, mechanical parts, 3D printing, CNC machining, PCB layout, and sheet metal fabrication. I've been using JLCPCB for my own engineering projects, including their custom STM32 development board, and the quality has been excellent. So if you're interested in building your own electronics, check out JLCPCB using the link in the description. Thanks again to JLCPCB for sponsoring this video. And now let's get started. 1 year ago, I saw this guy on YouTube. He turned an Arduino into the shape of Turkey, and my brain immediately said, how hard could it possibly be? So naturally, with absolute zero PCB design experience, I decided to make my own. Not because I needed one, because I apparently enjoy emotional damage. I decided to let Instagram participate in the design process. I asked it for a name and where the important components should go. That was my first engineering mistake.
One week later.
After about a week of waiting, it finally arrived. Ladies and gentlemen, months of work, countless hours, and approximately zero idea what I was doing. Now it's time to apply solder paste to all the pads because apparently I enjoy making my life unnecessarily difficult. Then came the fun part, placing every single component one by one. After spending what felt like an eternity placing every single component by hand, this is what it looked like. And honestly, I was pretty proud of myself. Now came the moment of truth. I plugged in the USB-C cable, clicked upload, and...
Psych! That's the wrong number!
The biggest mistake was the PCB layout itself. I placed the crystal oscillator as far away from the microcontroller as possible. So instead of building another board, I decided to build my skills. I started university, joined my university's rocket club, and spent the next year learning how real engineers actually design hardware. By the summer of 2026, I finally had the confidence to try again. But this time, I wasn't going to make another Arduino clone. I wanted something more powerful, more modern, and something engineers actually use. So I chose STM32. first blinking code, and it is working. So I'm using the ST-Link programmer to upload code over the SWD pins, and it's working. To test basic input output, and then PWM signal, which is this one, and then I'm using a potentiometer to do analog input and then also react with this pin, and I'm also doing digital input for this. So whenever I press, it is working. So this is digital input reading, and then another pin is reacting to it. This is just PWM signal from the microcontroller. This is blink every 500 milliseconds blinking, and then this is the potentiometer. Yep. So analog reading is also working. Yeah, everything is working. Okay, so right now I just uploaded my very first code over USB-C and it worked. So I have to make another program to show on video. So every time that I have to upload a new code to this one, I have to switch here and then connect the USB-C and restart it. Now in the code, the test code that I'm writing is blink every 500 milliseconds. So I'm just gonna make it faster by saying, instead of 0.5 seconds, blink every 0.1 seconds. So it's building right now. It says success. Now uploading the code. Oh, it failed. Let me restart it. Success. Oh my god, it works. It actually works. It works. This would be the PWM test. It is currently working. Okay, so currently testing GPIO input, and I'm using a button. So over here with the serial port, you can see button pressed, released. It's currently being pressed, released, pressed, released. So GPIO input with serial communication works. Okay, this test is analog input with potentiometer, and these are my output. This is the maximum, this is the minimum. With this one, I'm testing the I2C communication with the MPU sensor, and it is working. Okay, so with this, I have my dot matrix. I'm testing my SPI communication, and this is an animation from the matrix. And that is the story behind Turkmen32. This project taught me that failure isn't the end, it's just part of becoming a better engineer. If my first board had worked perfectly, I probably would have never learned half of the things I know today. I also want to give back to this amazing community that's been supporting me from day one. So here's the deal. If we can reach 1,500 subscribers on YouTube and 1,500 followers on Instagram, I will be giving away 2 Turkmen32 boards, one to a YouTube subscriber and one to an Instagram follower. Thank you all so much for watching. Thank you to JLCPCB for sponsoring this project and helping me make it possible. And thank you to everyone who supported me throughout this journey. Don't forget to like, subscribe, and follow me on Instagram for the giveaway. I will see you in the next one. Peace. Don't forget to tip.